Okay, in this video I want to try to explain how we find, do the calculations for distance to a planet or star. This is from the virtual astronomy assignment. So basically, in that assignment, they're asking you to calculate how long it's going to take to get to a distant object given a certain distance and speed. This is all based on this expression, rate times time equals distance. This is something that you should recognize from a long time ago, where rate, of course, is your speed. And so the idea is, for instance, if I go 50 miles per hour for 2 hours, I end up going 100 miles. And so the difference with these problems is they're actually giving you the rate and the distance, and they want you to find the time. So what we can do is we can take this expression and rearrange it and see that if we isolate time by dividing by the speed or rate, we get distance over rate, which might make more sense if we write it as distance over speed. And so it seems like we should just have to divide those two different things. There's a little problem here, though. So if we say time is equal to distance over speed, well, it makes perfect sense if we say we have to go 100 miles and we're going 50 miles per hour. The miles actually would cancel out and we'd get 2 hours, but that's because these two quantities are in the same units. In the problems that we're given, for example, when our distance is 46.1 astronomical units and our speed is 1,260,123. So that's 1,260,000 kilometers per hour. When we look at this divided, these units aren't the same. We can't just divide those two things because they're not in the same units. So we need to change the distance, which is in astronomical units, into kilometers. That will be really helpful. And so if we look up in our book or we look on the internet, we find that 1 astronomical unit is 149.6 million kilometers. And so what we want to do is we take 46.1 astronomical units and we use that, the equivalence that we just found. 1 astronomical unit is 149.6 million kilometers. And so these two things are the same. So this ratio is like equal to 1. And what it does is it allows us to change our units, and now our new units will be kilometers. So we just take the 46.1 times the 149,600,000, and that's going to give me the distance in kilometers. And that turns out to be 6.896 times 10 to the 9 kilometers. So that's the distance to our object in kilometers. Now, if we want to find the time, we take 6.896 times 10 to the 9 kilometers, because remember, that's the same as 46.1 astronomical units, but it's just in the right units. And then we divide by our speed, which is 1,260,000 kilometers per hour. Notice our kilometers is going to cancel, and our value is going to be now in hours. So that's how long it's going to take us to get there in hours. But they ask us how many days, so we want to change units again. We know a day is 24 hours, so we just have to make another ratio. 24 hours is 1 day. And the way that we know which goes on top and the bottom is so that we can cancel out our units, just like fractions. And so taking this number and dividing by 24 is going to give us the time in days, and that's 228 days. And just to kind of go one step further than they ask us to, we could take 228 days. We could also calculate into years and say 365 days is 1 year, and that would be 0.625 years. So that's basically what you're running into in terms of trouble with these problems, is if you're not making sure that everything is in units, that things will cancel out. Like here we had the kilometers have to be able to cancel out, and then my time is measured in hours. So everything has to be consistent, and this conversion idea of making a fraction that is equal to 1 because both these quantities represent the same amount, but they're in different units, and putting them so that our units will cancel out, that will tell us if we need to divide or multiply our numbers. So hopefully this is helpful for tackling those problems.